This video will cover spindle drive installations in Fadal machines. The typical tools are shown here. The extension is nice to get to the back. It's also a very good idea to make some photos of the existing installation of where all the wires are going and the colors. Leave the bottom bolts installed. Don't pull everything off. You'll basically rest the drive, and the nuts that are backed off on the bottom lugs will be useful to hold the drive in place as you put the nuts at the top of the drive. Basically, once all those nuts are tightened down and the drive is in place, you might want to back off all the terminals on the terminal strips as far as the screws will go. It will be helpful because some of these wires are pretty large and they'll require the screw to be fully backed out. Some drives might also have used rings on the end of the wires. If the rings are there, you'll have to cut those rings off and strip the wire before you put it in. Here we're putting in the L1, 2, and 3, which is the incoming power. This is the regen resistor. Some Mitsubishi drives might not have an external regen resistor, so you will definitely need to have a regen resistor. We do sell the regen resistors. You'll want the regen resistor to be somewhere in the range of 11 and 30 ohms. If you go too small on the ohmage, you'll cause some problems of either the bus current will be too high, or it'll the bus voltage will be over voltaged. This is the T1, 2, and 3. The numbers are important when there is a spindle. Their motor has an encoder and you're in vector mode or in censored mode. The T1, 2, and 3, when there's no encoder and you're in the VFD mode, those can be swapped to get the spindle motor turning in the correct direction. But the vector drive, it has to be the specific way. Now here we are putting the spindle load meter terminals on. Some drives might be opposite, so please look at the silk screen above this terminal. It'll tell you which one the black wire goes into and which one the red one goes into. It might be opposite on your previous drive. Just make sure you follow the color codes there. The 6-pin on the left connector is the spindle on, the fault line, and things like that. In the silk screen it tells you about that. The square connector next to it is the encoder. You might not have that. Here we're putting the encoder in if you have rigid tapping. This green connector is what goes back to the access card. You might not have that. Here I am cutting the wire ties. Sometimes the wire ties are pretty tight and it's hard to position the wires in place. You'll want to make sure the colors are going into the correct spot. You can refer to our documentation. This is fairly standard on most cables. There is an alternate wiring if you don't have the yellow, brown, green, red wires. But yellow, brown, green, red wires is typical on most cables. So this last connector, that's just a high gain, low gain thing that's typically on Baldor drives or AMC drives. It's not used on the Glentek version, so I'm not going to put it in. If you have a wye-delta, there'll be more wires, but if it's just that single pink wire, you can leave that out to avoid any issues. It won't typically matter if it's inserted, but I did not put it in because the drive doesn't use it anyways. Here I am verifying all my connections. I verify the wires go to the correct terminals and making sure all the wires are in the right spot. I haven't forgotten to put in any wires. You want to make sure all the wires are in place. I'm checking my nuts, making sure that they're tight and holding the drive in place. And just to repeat, I did not plug in that one pink connector because it's not used on this drive. You can tie that back. When it powers up, there'll be a letter C. That's the status. It's clamped. Clamped means it's in the stopped position. 0 is the RPM. It'll stay clamped, or it's not an error. It's just telling you that it's in a stopped position. When you go back to the Fadal control panel, you'll want to run the spindle in 2 different directions. Make sure the spindle pot is off with an M49. Run it in M3, then M4, and you'll want to see the RPM to be exactly the same in both directions. And you'll see that that C turns into a little line that rotates. Here's I programmed S500. The motor is actually turning at almost 1,000, which is this because it's a 2-to-1 ratio. So the motor's turning twice as fast as what the spindle is. So I now go back and I type in an M4, and you can see that it is perfectly balanced. It's 994 in both directions. If you need to, there's a small pot you can rotate to make sure that the number is the same in both directions, M3 and M4. There's also a signal gain pot right next to the balance. You can turn that. It is set at the factory, but that will allow you to, if you can't get to 10,000 RPM, you can rotate that signal gain pot to make sure the RPM goes all the way as high as it can go. Here it is coming to a stop again, checking the RPM. And here I just adjust the signal gain up, and so that the motor's turning at exactly 1,000, just to kind of show you that you can do that. It's not necessary unless you have some sort of RPM issues. So now it's spindle stopped. It goes back into the clamped position, which is correct. The other error codes are in our manual if you need to reference them. Now we're going to show our handheld. This is an option if you want to have more control. You can look at the balance and the RPM at the control. Here I am entering M3, M49, S500. When we run it, we can go up and select balance RPM. It's going to show the balance, or show the RPM on the screen, and then I change it to M4 and go the other direction and make sure that the balance is perfectly accurate. With the handheld, you can actually adjust the balance with left and right buttons. Otherwise, you can do this at the pot at the back. You can also configure new drive types, but it is working correctly, so I'm not going to change anything. This is just an option that we offer. That's basically the installation of the spindle drive into the Fadal machine.